Okay, so moving on to algebra, and we're looking at index laws to start with. So we know with index laws, we've looked at this when we have powers that are getting multiplied together when they have the same base number. These powers can be added together, so 2 and 3 would make 5. We also had the process when they're being divided. So x to the power of 7 divided by x squared, we take away the powers and we get x to the power of 5. And we also have powers in brackets, so if we have x squared to the power of 5, we multiply the powers, so we get x to the power of 10 in that particular example. Now having a look at this one, we've got 30x squared y to the power of 3 on the top and 6xy squared on the bottom. So we're doing a divide. Now we've got these numbers on the top and the bottom, 30 on the top, 6 on the bottom. So numbers always just divide numbers, so 30 divided by 6 gives us 5. Now individually looking at the letters, we've got an x squared, and on the bottom we've got an x. Now it's not written in there, but that is a little power of 1 there that's not written. So if we subtract the powers, 2 take away 1 gives us x to the power of 1. I'm not going to write that in, I'm just going to leave it as x because that means x to the power of 1. Moving on to the y's, we have y to the power of 3, y squared on the bottom, and 3 take away 2 gives us just y on the bottom there. So our final answer would be 5xy. Okay. Looking at this one then, we've got powers in brackets, so we're going to be multiplying powers here. But we've got this number 2 in the start as well, so numbers always get treated like numbers, and that whole thing is being cubed. So we need to work out what 2 cubed is. 2 cubed is 2 times 2 times 2, which is 8. So we're going to have 8 at the start of this one. Multiplying the powers for the x then, x to the power of 2, that's going to get times by 3, so that's going to become x to the power of 6. And y there is a power of 1 which is not written, so 1 times 3 gives us y to the power of 3. And there's our final answer there. On to expanding brackets. This first bracket we are multiplying everything inside the bracket by b. So b times 3b, well not forgetting there's a 1 in front of that, 1 times 3 is 3, and b times b is b squared. On to the next one, 1b times 7, well 1 times 7 is 7, and there's just that 1b that we're going to leave in there, and we're just going to copy that symbol, which is a plus, so keeping that as a plus. On to expanding below, we have 3y times 5. 3 times 5 is 15, and we've got the 1y there, so we'll leave that as a y. And then 3y times the 4y, well 3 times 4 is 12, y times y is y squared, and then again copying that symbol as a negative. Expanding and simplifying two brackets, so we'll expand these separately, so let's have a look at the first one. So 3 times 5 is 15, and 3 times 4 is 12. So we have 15x plus 12. On to the next one. Got to be careful with this one because it's saying take away, which means this is a negative 2 at the start of the bracket. So we're going to times both these pieces by negative 2. So negative 2 times 3x is negative 6x. And negative 2 times negative 2 gives us positive or plus 4. Now we just need to tidy all this up, so we have a 15x take away a 6x, and that gives us 9x's in total. And we have a 12 add a 4, and 12 add 4 is 16, that's positive 16, so we get 9x plus 16. Moving over to expanding and simplifying a double bracket. So x times x gives us x squared. X times negative 5 gives us negative 5x. 3 times x is positive 3x. And then positive 3 times negative 5 is negative 15. And then again, we just need to tidy this up because we've got these two x pieces in the middle. So we've got x squared still at the start, but we've got negative 5x add 3x, which in total is negative 2x, negative 5 add 3. And then we've got the negative 15 at the end. Onto the one below. So we've got some numbers in front of the x's here, so I'm going to do the same process. Let's see if we can move some of this out of the way. Just about. Okay, so 2x times 3x, 2 times 3 is 6, x times x is x squared, so we'll get 6x squared. 2x times 4 is 8x, that's negative 4, so it's negative 8x. Negative 3 times 3x is, well 3 times 3 is 9, so negative 9x. And then negative 3 times negative 4 will give us positive 12. 3 times 4 is 12, and it's a negative times a negative. And then again, just tidying this up, we we have 6x squared at the start, and we've got negative 8 take away another 9x. So negative 8 take away another 9x is negative 17x. And then we've got that plus 12 at the end, and there's our final answer. And we've simplified it there with the simplifying in the middle. Final answer. Okay, so factorising. We're going to take out a factor and put this into brackets. So we have a look at both these pieces, 3x and 15. We just think what number goes into both of those. They both divide by 3. So we're going to divide this by 3. So 3 on the outside of the bracket, that's the factor we're taking out. 3x divided by 3 is just x. Copy the symbol with a plus. And 15 divided by 3 is 5. And you can check your answer there. You can expand that back out just to check that you do get 3x plus 15. Now this next one says factorise fully, and that's because there's more than just one thing that comes out of the bracket in this one. So in that one above there was just a 3 that came out. So here we're going to have 2 things. And let's have a look at both these pieces. So we've got 35x and 21x squared. So they both have an x in, so there's definitely going to be an x coming out. Just need to think with 35 and 21, what's the biggest number that goes into both of those? That is 7. So the highest common factor of those two numbers is 7. They also both have an x in, so we can take x out as well and then follow the same process. So 35x divided by 7x, or what do we times 7x by to get 35x? We'll have to times 7x by 5, but we don't want to put an x in there because we don't want to make that go up to an x squared. Copy the symbol. We times 7 by 3 to get 21, but we want that to be an x squared. So I'm going to stick another x in there with it. That would enable us to get an x squared when we expand that. And there's our final answer, factorised fully. Just a note, if you didn't take the 7x out and you just took a 7 out, for example, and this wouldn't be factorised fully, you'd have got 7 brackets 5x minus 3x squared. And you can see in that bracket there, there's still an x in both these pieces. There's a little hint there that you didn't fully factorise it. Okay, so on to factorising a quadratic. This is the opposite of expanding a double bracket, so we know what our answer is going to look like already. It's going to be in a double bracket, both with an x at the start. Now when we're doing this, we've just got to find the pair of numbers that are going to go into our bracket. So looking at the 12, we know it's going to be a pair of numbers that multiply to make 12. So I always write these down. We can have 1 and 12, 2 and 6, or 3 and 4. Now we just need to have a look at these numbers there because we've got a 7x in the middle, so they have to add up to make 7x. So 1 and 12, there's no way I can make 7. 2 and 6, I could either make 8 by adding them together, or I could make 4 or minus 4 if I do a minus with one of them. So I'm not going to make 7, but I can make it with 3 and 4. I can have plus 3 and plus 4, and that would make 7. So plus 3 and plus 4, and that's not a 4, plus 3 and plus 4, and that would be factorised. Having a look at the one below, we've got some negative symbols going on there, so we've got a slightly different process, but our answer is going to look the same. It's still going to be in a double bracket, it's still going to be x at the start, and we're still going to have 2 numbers in here with some symbols. So 28, the numbers that times to make 28 are 1 and 28, 2 and 14, or what else could we have? 4 and 7, and let's have a look if these can make 28. So what have we got? We've got minus 3 in the middle. So we want to make minus 3. Well, we're not going to do that with 1 and 28. That's not going to work. 2 and 14, we could make 16, or we could make 12. That's not going to work. But 4 and 7, we could do plus 4, take away 7, and that would make minus 3. So plus 4 and negative 7. And that's our double bracket there finished. So on to solving equations. So when we've got this word solve, it means it wants us to find the value of this x piece just here. So we've just got to reverse the process of what's going on. So at the moment it says 3 times a number, 3 times x, plus 5 is 26. Well, if we get rid of this plus 5 by taking away 5 from both sides, that tells us that 3 times a number, 3x, must equal 21. And that means 3 times a number, so we can reverse this process now by dividing by 3, which I like to write as a little fraction, so divide by 3. And 21 divided by 3 is 7, so we would write x equals 7, and there's our final answer. So have a look at this next one. So 5x minus 2 equals 21. Well, this time to reverse this, we've got 5 times a number, take away 2, so if we add the 2 onto both sides, we get 5x equals 23. And here comes the part where I explain why I like to write it as a fraction as above rather than just writing divide by 3, because in this circumstance 23 doesn't divide perfectly by 5. So if we go divide by 5 again and divide by 5, we have our answer there written for us, 23 over 5. So x equals 23 over 5. Okay, which we could convert back into a mixed number. 5 goes in 4 times with the remainder of 3. So we could write it's 4 with that remainder of 3/5 there. Or I could even write it as a decimal. I could type that into my calculator and turn it into a decimal, but it's fine to leave it as a fraction. 4 3/5 is my answer. So here's one we've got x on both sides of the equation. So in order to make this look like one of the equations from before, we want to get rid of x from one of the sides. Now it doesn't matter which one we choose, I always choose to go for the smallest x. So we've got a 5x on one side and a 3x on the other side, so 3 being the smaller one. So we can take away 3x from both sides, that's smaller x. So if we take away 3x from both sides, well 5x take away 3x leaves us with 2x. We've still got that negative 3 there, and that now equals positive 9, so I won't bother putting the positive symbol. However, if there was a negative there, I would keep that in, just to emphasise that it is a negative 9, that's really important. So now we've got an equation just like the question before, so again we can add 3 to both sides, and we get 2x equals 12, and then we can divide that by 2. Again, I like writing that as a fraction, and 12 divided by 2 is 6, so we can write that as a whole number, x equals 6. Make an x the subject of a formula, or any letter the subject of a formula. So this one's y equals 3x plus 5. So essentially, to make x a subject, we want it to say x equals. And we're going to rearrange these pieces and move them around, just like we did on that solving the equation. So the first thing I can do is I can get rid of that 5, just like before, and we can subtract 5 from both sides. Now I can't actually subtract 5 from y, so I'm just going to write that as y minus 5. And that now equals 3x. And just like before, we're just going to divide by 3. So if I divide by 3 both sides, thinking about how I did it before, I wrote it as a fraction like this, and that's what it's going to look like on the other side. It's going to be y minus 5 over 3 now equals x. 3x divided by 3 is just x. We've got x on its own. It doesn't matter that it's on the right hand side. We can rewrite it if we want. We can easily just rewrite x equals y minus 5 over 3, and there's our final answer. Got two slightly different ones here that look almost the same because we've got some fractions going on, but let's see how we treat these ones. So on this left, make x the subject. So again, what I could do is I could get rid of this 3 on the bottom to start with if I wanted, or I could get rid of this 5. I'm going to decide to get rid of the 5, so let's take away 5 from both sides. So if we take away 5 from both sides, we get y minus 5 equals x over 3, or x divided by 3. So to reverse a divide by 3, we're going to have to times by 3. So if I multiply both sides by 3, we'll get 3 lots of, and I'll put it in a bracket now, 3 lots of y minus 5 equals x. We could leave it like that, or we could expand this. We could say 3 lots of y is 3y, 3 lots of 5 is 15, copy the symbol, and then put in our x. Again, we could have done that a slightly different way. We could have times by 3 to start with. You'd have just had to remember at the starting point we'd be timesing this by 3, and we'd be timesing this by 3, just like we did in the end there. But that's our final answer. Now looking at this one on the right, it's slightly different because we don't have the option of getting rid of this 5 on the starting process here, because it's locked in by this divide by 3 on the bottom. So the first thing I'm going to have to do is times by 3 to remove this fraction to unlock what's on top there. And if we times by 3, we get 3y equals, and what's on the top is x plus 5. Now we can finish it off quite nice and easily. We can just take away that 5, and again that's going to make x the subject. So we have 3y minus 5 equals x, and again both of these questions we could rewrite it as x equals at the start if we wanted. So a equals 5b plus 2c, b equals 3 and y equals negative 2, find the value of a. So we're just having to substitute these numbers in. So we're going to find out what a is. So a is going to equal 5 lots of b, and when I sub a number in I always put it into a bracket. So we have 5 lots of b, which is 5 lots of 3, and then 2 lots of c, so plus 2 lots of negative 2. We put these in a bracket like that. All we have to do is now multiply these. So 5 times 3 is 15. 2 lots of negative 2 is negative 4. And we're adding these together. So 15 add negative 4 is 11. Remembering that these just become a takeaway. So it's 15 take away 4. So a would equal 11. There you go. Just something to remember there. Whenever you're subbing numbers in, always put them into a bracket there, just so that you can sub them in and then deal with the calculations later. Okay, so on to solving simultaneous equations. Now we've got two equations here. I'm going to call this one 1 and this one equation 2, just so that I can talk about them. So when we're solving simultaneous equations, we want to make the coefficient, the number in front of one of the letters, the same. Now I always focus on this second one here, which in this case is the y. So on the top one we have 1y, and on the bottom one we have 3y. I know one of them is negative, but we'll deal with that later. I'm just purely looking at the number in front of it. So we have a 1y and we have a 3y. Now in order to make those numbers the same, I'm going to have to times the top one by 3, and that would make it a 3y. I don't have to times the bottom one by anything, but I might have to change them both in some of these questions. So let's have a look. If we multiply this top equation by 3, what does it become? So 4x would become 12x, the 1y becomes the 3y, and the number at the end will become 75. And that's my top equation. I'm going to rewrite the other one below it, which was 1x minus 3y equals 16. Now at this point I have the option, I can either add these two together or I can subtract them away from each other, but I want this 3y in the middle to get eliminated. Now if we think about the logics here, if I was to do 3y take away negative 3y, that would become a plus and I'd end up with 6y. So taking them away is not going to work, I'm going to have to add them together. 3y add negative 3y becomes 0. So if we add these two equations together, we get 13x equals 91. Okay, so there is a little way of remembering those. If those symbols there are different, you add them together, and if the signs are the same, you're going to subtract them. Okay, but here we are, we have 13x equals 91. If we divide both sides by 13, we get x equals 7. Now when it comes to simultaneous equations, we have to not just find the value of x, but we also have to find the value of y. So what I'm going to do is I'm going to sub x equals 7 into any of these equations that we've got written down. I'm just going to have a look at the start. I think this one's going to be the easier one for me, just because it's got a plus symbol. So if I sub x equals 7 into equation 1, I won't have that x there anymore, and we can start to work out what it is. So again, using brackets, I'm going to do four lots of 7, add that 1y, and that equals 25. Now 4 lots of 7 is 28, so we have 28 plus y equals 25. And again, we just need to now finish this off to solve it to find out what y is. Well, 28 add y is 25, it goes down, so it's got to be negative. If we solve this like normal, take it away 28 from both sides, we get y equals negative 3. And there's our final answer, y equals negative 3. So x equals 7 and y equals negative 3. I could have subbed this x equals 7 into any of the equations. I could have subbed it into equation 2. I could have even subbed it into this equation that we made up here if I wanted, but I think I just went for the easiest one there. So let's have a think. If I did sub it into equation 2, we'd have had 7 take away 3y equals 16. Doesn't quite seem as nice here, because now when we take away 7 we have negative 3y equals 9 when you take away 7, and then when you divide by negative 3, 9 divided by negative 3 is negative 3. So we could have solved it in that equation as well, but I've opted to go for the easier one there. Okay, so we've got some worded equations here. 3 calculators and 4 books cost £23, and 2 calculators and 3 books cost £16. Work out the price of a single calculator and a single book. So we have to create the equations ourselves here. So let's have a look. We've got 3 calculators and 4 books cost £23. Well, let's just call the calculator C, so 3C, and, so plus 4 books, let's call that B, equals 23, and we've got an equation there that looks similar to the last question. The next statement, we've got 2 calculators, so 2C, add 3 books, so 3B, equals 16. There we go, so we've got again an equation 1 and an equation 2. Now we've got to follow that same process as before. I'm going to make these numbers, these coefficients of B the same, but this time I'm going to have to change them both, because one's a 4, one's a 3. So let's think, we could make those into 12, so I could times the top one by 3, and I could times the bottom one by 4, and that would give me a 12 in the middle. So if we actually work that out, let's have a look, what do we get? Timesing the top one by 3, and let's move this around. Okay, so timesing the top one by 3, we get 9C plus 12B, and 23 times 3 is 69. Onto the one below, timesing them by 4, we have 8C plus 12B, and 16 times 4 is 64. Okay, so looking at these symbols, the signs are the same, they're both a plus, so the way to eliminate this 12b is to subtract these away from each other. So I'm going to do the bigger one on top, take away the smaller one on the bottom. So 9c, take away 8c, leaves us as 1c. And 69 take away 64 is 5. So straight away we get our answer there, c equals 5. So there's our first answer, c equals 5. And then we just need to sub that back into one of these equations. Again, I'm going to pick equation 1, I think. Let's have a look. We could do either one here, but I'm going to pick equation 1. So if c is 5, we have 3 lots of c, or 3 lots of 5. Add 4b, and that equals 23. There we go. Now 3 lots of 5 is 15, so we're going to have to take away 15 from both sides, and we get 4b equals 23, take away 15 is 8. And then dividing that by 4, we get b equals 2. There you go, 8 divided by 4, b equals 2. So our final answer there, we got c equals 5 and b equals 2. Obviously thinking about the context here, that was a calculator is £5 and a book is £2. So Adam, Brian and Chris are all work colleagues. Adam is 8 years older than Chris, Brian is twice as old as Adam. The sum of their ages is 92. How old are they all? Okay, so we can do this using equations as well. Now it says Adam is 8 years older than Chris and Brian is twice as old as Adam. Now it doesn't say anything about how much older Chris is than anyone else. So if let's call Chris X, then what would Adam be? Now it says Adam is 8 years older than Chris, so Adam would be 8 older than that, exactly 8, so that would be whatever Chris's age is, X plus an extra 8. Then it says Brian is twice as old as Adam. Well, this is Adam here, X plus 8, so Brian is twice as old as that. So twice as old as that would be 2 lots of that, so 2 lots of X plus 8. And we could even expand that out now, so 2 lots of X plus 8 is 2X plus 16. So we have their 3 ages now in terms of algebra. We have Chris being X, Adam being X plus 8, and Brian being 2X plus 16. It says the sum of their ages is 92, so sum being to add them together. So if we add them all up and see what we get, we can have X plus the X plus 8 for Adam, plus the 2X plus 16 for Brian. And it says that they all equal 92. So if we start to simplify this, let's have a look. We've got x, x and 2x, which is 4x. And we have the 8 and the 16, which is 24. So 4x plus 24 equals 92. And now we can just solve this just like before. So I can take away 24 from both sides. Take away 4 is 88, take away 20 is 68. So we get 4x equals 68, and then we just need to divide by 4. So dividing that by 4, let's think, gives us 17. So x equals 17. So it does say how old are they all, so we could finish this off and we could just say, well, Chris was x, so Chris is 17. Adam was x plus 8, so Adam would be 17 plus 8, which is 25. And then Brian is twice as old as Adam, so Brian would be 50. Twice as old as 25, double 25. A nice little quick check there, you could just add those all up. 50 plus 25 is 75, plus the 17 is 92. So I'm happy that that works, it meets all those criteria. So the perimeter of the quadrilateral is double the perimeter of the triangle. Work out the perimeters. Now the lengths of each shape are given to us as expressions, so we could get an expression for each of the perimeters to start with. So let's have a look at that quadrilateral. Let's write that down over here. So the quadrilateral, we've got lots of pieces here, so let's count up these x's to start with. We've got 2x, plus this one's 4x, 7x, plus another one is 8x, so we have 8 x's. And the numbers, we've got a -3 and a -1, and in total that is -4. So that's the quadrilateral, 8x minus 4, and that's an expression for the perimeter. Then we've got the triangle. Let's have a look what we've got there. We've got 1x, 2x, so 2x, and we've got 3, 4, 5, plus the 4 is 9, so 2x plus 9. Now it says the perimeter of the quadrilateral is double the perimeter of the triangle. So if we double the perimeter of the triangle, then that would be equal to the perimeter of the quadrilateral. Okay, so if we double this one, then those perimeters, those expressions for the perimeters would be equal. And if we double that, we get 4x plus 18. Now because those two perimeters are now equal, we can set them equal to each other using an equation. So we can say this one here, the perimeter of the quadrilateral now, 8x minus 4, is equal to this one here, double the perimeter of the triangle. So that's equal to 4x plus 18. We can now just solve that like an equation, so we can get rid of the smaller x from both sides, so minus the 4x. So over here we have 4x, so we have 4x minus 4 equals 18. We can now add 4 to both sides, so get rid of this plus 4, so plus 4. And we get, let's do this over here, we get 4x equals 22. And then we've got to finish that off to find out the value of 1x, so dividing by 4, x will be 22 over 4, which is okay if we have a calculator, but 4 goes into 22 5 times with a remainder of 2, so it'll be 5 2/4, and 5 2/4 is 5 1/2. So our final answer there, let's bring that up to here, would be 5.5 or 5.5. And again, it would have probably said in the question it was all in centimetres or it was all in metres, so we just have a look at what units we'd apply there, but 5.5 is our value of x. Now it says to work out the perimeter of the triangle, so we can sub these back in if we want. So 5.5 would be here in place of this one, would give us 8.5, so that would be 8.5. 5.5 on the x plus 2 here would give us 5.5 plus 2, which is 7.5, and then this one over here is 4. So if we add those all up, 8.5 plus 7.5 is 16, plus the 4 gives us a perimeter of 20 for the triangle. We could have done the same with the quadrilateral, but it said the quadrilateral is double the triangle, so this one here must be 40. And again, we could have just subbed that into the quadrilateral there and halved it for the triangle, but we've got our two perimeters. Again, just not forgetting what units it was, not that I've put any units in this one. Okay, so work out the size of angle ABC in this pentagon. So A to B to C is this angle here, and that's got a 2x in there at the moment. Now it's a pentagon, it doesn't say it's a regular pentagon, it's definitely not because all the angles are different. But we need to know what the angles are in a pentagon this time. So a triangle, remember, is 180. A quadrilateral, we add another 180, is 360. And then a five-sided shape, we add another 180, which is 540. So 540 degrees is what these all add up to. Now if we add them all up, again, like we did before, we've got 2x, plus another one is 3x, plus another one is 4x. So we have 4x's, plus all these numbers. So we have 121, 112 and 15. And if we add those all up, 121, 112 and 15, we get 842 or 248. So plus 248 has to equal 540 degrees this time. And there's our equation made because we know all these angles have to add up to 540. So we've got slightly bigger numbers here, but let's take away 248. Take away 248 and it will tell us what those 4x's have to equal. So 540 take away 248 gives us 292. So 4x equals 292. And if we divide that by 4, it will tell us what the value of 1x is, and 1x comes out as 73 degrees. I'm not quite finished the question here because it does say for work out the size of angle ABC. Now the size angle ABC here is 2x, so 2 lots of 73, 2 lots of x is 146 degrees. So that one there would be 146. Again, we could work out any of these, we would know that that one now is 73. And x plus 15 down the bottom here would be 73 plus 15, which would be 88. And if you add those all up just to double check, you will get 540 degrees, but our final answer there is 146 degrees. Okay, so a nice quick one here, solving an inequality. Now this symbol shouldn't put you off here. It's an inequality, yes, but we're going to treat it exactly the same as if it was an equal sign. So before we saw a question like this where it was 2x plus 3 equals 20. We're going to do it in exactly the same way, but we're just going to leave that symbol in there. So we're going to take away 3 from both sides, which leaves us with 2x is less than 17, and then dividing by 2. We get x is less than 17 over 2, and we could probably work that out. 17 over 2, half of 17 is 8.5, so x is less than 8.5. So find an expression in terms of n for this sequence. So we're going to do the nth term, and then it says hence find the 50th term. So what I always like to do is draw these little loops just to see what times table this is related to, and from 3 to 7 it goes up by 4, and then it keeps going up by 4. So this is related to the 4 times table. Now the expression for the 4 times table is 4n, if we do it in terms of n. Now this is obviously not the 4 times table though, is it? Because the 4 times table, if I write it above, is 4, 8, 12, 16, 20. And all of these numbers are 1 less. Look, from 4 to 3 is -1, from 8 to 7 is -1, so it's the 4 times table, but it's had 1 taken away, and that is our nth term there in terms of n. There is also a little trick that you can apply on this. You can go backwards 4, so if we go back 4, we get the number -1, and that always tells us how much smaller or how much bigger it is than the times table we're looking at. So it says hence find the 50th term. Well, here's our little code, 4n minus 1. To find the 50th term in the 4 times table, you do 4 times 50, and it's no different for this one, but it's the 4 times table take away 1. So we're going to sub it in, and we get 4 times 50, or 4 lots of 50, but then we have to take away 1. 4 lots of 50 is 200, and 200 take away 1 gives us 199, and that is our 50th term. Just thinking, if you didn't have this nth term, you'd have to just keep counting up from 19, so you'd go 23, 27 and so on, and you'd have to keep counting up to the 50th term, and it'd take you quite a long time, so this is a nice little shortcut for that. Here's another one, find an expression in terms of n for this sequence, and then will 84 be in this sequence, explain your answer. Let's have a look. It's going up in fives, so our expression for the 5 times table is 5n, but this is not the 5 times table because the 5 times table goes 5, 10, 15, etc. So 6 is 1 bigger, 11 is 1 bigger, so it's the 5 times table, but it's got 1 added on, so that's my nth term this time again. We could have gone back 5, which would have given us the number 1, which is a positive one, and that's just another way that we could have a look at it. Now it says, will 84 be in this sequence, explain your answer. Now, there's two different ways of doing this. This one in particular I'd like to use more of a logical approach. So if you have a look at all these numbers, 6, 11, 16, 21, 26, they all end in 6 or 1. So I would be able to say no, because all the numbers end in 6 or 1. Okay, because they all end in 6 or 1. But there is another way of doing this. There we go, they all end in 6 or 1. Okay, so that's option 1. There is another way, because it might not be that there's a pattern, so my second option is I can actually just make an equation. I can just say, well, does 5n plus 1, does it ever equal 84? And that's what that means there. Does 5n plus 1 ever equal 84? And we can solve that. So taking away 1, we get 5n equals 83. And then if we divide by 5, we get 83 divided by 5, which is not a whole number. So I could say no, n's not going to be a whole number, the position is not going to be a whole number. Okay, so not a whole number. Now I'd obviously just have to make that statement, no, not a whole number. Okay, so draw the graph of y equals 2x minus 1 between the values of x equals minus 2 and x equals 3. Now there's two ways of doing this. Again, we could make a nice little table, and we've got x values and we've got y values. Remembering this equation just means to find the y coordinate, you do 2 times the x coordinate or double the x coordinate and take away 1. Now it says between minus 2 and 3. So if I'm going to do a little table, I'd do minus 2, minus 1, 0, 1, 2 and 3. And all I've got to do is double them and take away 1 as the equation says. So if I start at the end with this positive number, double that is 6, take away 1 is 5, double 2 is 4, take away 1 is 3. Double 1 is 2, take away 1 is 1. Now you might start to see there's a bit of a pattern here. Look, 5, 3, 1, those are all going down in 2s. So I can just follow the pattern here. 1 take away 2 is minus 1, and take away 2 again is minus 3, take away 2 again is minus 5. And we've got our coordinates here. Just looking at this one, that coordinate is minus 2, minus 5 as a coordinate. And all we've got to do is plot these and join them up with a ruler. So that's one way that we can do it. And I'm going to just draw that in to start with. So minus 2, minus 5's here, minus 1, minus 3, 0, minus 1, and the next few go there. And then nice and neatly with a ruler and a pencil, joining that up with a straight line. Absolutely not like I've just done there, which is absolutely terrible, but as best as you can with a straight line and a ruler. Okay, so that's one way that you can do it with a little table. You can actually do a little trick with this one, which is quite nice if you know what these pieces in there mean. So the 2 in front of the x, let's draw this over here, y equals 2x minus 1. The 2 there represents the gradient, and the minus 1 there represents the y-intercept. Okay, where it crosses the y-axis. So let's have a look there. It does cross through minus 1, so we could have put that point on straight away because we know it goes through minus 1, and then we could have had a look at the gradient, and that gradient of 2 just means for every 1 across, let's think from that point, so 1 across, it goes 2 up, and it goes 2 up. So you could do a little staircase here. You could just go again, 1 across, 2 up, 1 across, 2 up, to keep finding those coordinate points, and then tracing it backwards, so 2 down, 1 left, 2 down, 1 left, and you can draw this little staircase in. That's another way of doing it as well. Slightly different one, so draw the graph of y equals x squared plus 2x minus 3 between minus 3 and 2. Now again, I'm going to do a little table for this. So we have x and y, and it's between minus 3 and 2. So minus 3, minus 2, minus 1, 0, 1, 2. Now this is a slightly more complicated one for us to sub in, because to find the y coordinate you have to do x squared, add 2x, take away 3. So I want to write these down nice and carefully. So I'm going to start with 2 again for the positive one. So we have 2 squared plus 2 lots of 2 take away 3. I'm just going to work that out nice and slowly. 2 squared is 4 plus 2 lots of 2, which is 4, take away 3. So 4 plus 4 is 8, take away 3 is 5. So my answer there underneath the 2 is going to be 5. Now I need to follow this process for all of them, but the one thing I do need to be careful of is when we get to these negative numbers. So up here, where I put 2 squared in, just here, we should really make sure we keep that in a bracket, because as we get down to those negatives, it's going to have a big effect on that, and we'll see what happens when we get to them. Now I'm going to do the other ones a little bit quicker. Let's have a look. So 1 squared is 1, add 2 is 3, take away 3 is 0. 0 squared is 0, add 0 is still 0, take away 3 is negative 3. And here's where we need to be careful. So the first one here is negative 1. So I need to put, if I'm going to do this on a calculator, I'll write my working out down. Negative 1 squared, add 2 lots of negative 1, and then take away 3. Now the reason you have to put this in a calculator is because if you put negative 1 squared without the brackets, it will give you the answer negative 1. It will square the 1 and put the negative with it rather than doing negative 1 times negative 1. Squaring a negative number makes it positive, so negative 1 squared is 1, add 2 times negative 1 is negative 2, and take away 3. So 1 take away 2 is negative 1, take away 3 is negative 4, so we get negative 4 for that one. There we go. Let's have a look at the next one. Negative 2 squared is 4. Add negative 4 is going to be 0. And then take away 3 gives us negative 3 again. And then onto the negative 3. Negative 3 squared is 9. Add 2 lots of that, so negative 6. So 9 take away 6 is 3. And then take away 3 again gives us 0. So you can probably see a little bit of a pattern here. Look, if you look at that negative 4 in the middle, either side of that we've got negative 3. Either side of that we have 0. And then we have the additional 5 there. But let's just plot these and see what it looks like. So negative 3 to 0 is there. Negative 2 to negative 3 is there. Negative 1 to negative 4 is here. 0 to negative 3. 1 to 0, and 2 to 5, which is all the way up there. There we go. So this forms a quadratic curve, a parabola, and we just need to draw that with a nice smooth curve, as best you can, going through all the points, making a nice smooth curve. And there's our graph drawn. Just as a note, we could also have a cubic graph. So we could have an x cubed up here, and we just treat that in exactly the same way, subbing the numbers in very carefully using brackets. And it tends to be that a cubic graph has this sort of shape. So just be careful. There are some others as well. We could have a reciprocal graph where we have something like y equals 3 over x. And that has a different look again. It has this sort of curved shape within the positive part of the graph. So there's lots of different graphs that we can have a look at, but just treat it all in the same way and plot the points very carefully, joining them up with nice smooth curves. Okay, so back to a straight line graph. Find the equation of this line and give it in the form y equals mx plus c. So I'm going to use that little trick process that I saw before. We're going to have a look for 2 coordinates here. I've got 1 coordinate there and another coordinate here. Now if we go across 1 on the x-axis, being careful of the scale here, because although mine goes up in ones, sometimes you might have 2 squares for every one, so just be careful of that. Now it goes across 1 and then it goes up 2. So it goes across 1 and up 2, so every 1 across it goes 2 up, so the gradient, the value of m, is 2. All we've got to find is that value of c, which as we've already said is the y-intercept, and it crosses the y-axis down here at negative 3. So c is going to be negative 3. So I just need to put those all together. We have y equals 2x take away 3. That's the equation of this line. We can do that nice and quickly like that. It goes through negative 3 on the y-intercept, and there's a gradient of 2, which I've found between those 2 whole number coordinates there. Slightly different one here because it's sloping in the other direction, but the same type of question. I'll take the same approach, so I'm going to find the y-intercept to start with this time, so c equals 1, and then we just need to find the gradient. So let's pick 2 coordinates. We've got 1 here and 1 here, and now this time for 1 across it goes 2 down, so 1 across it goes down 2. So my gradient this time is going down, and we'd say it's negative 2, so the gradient is negative 2. So y equals mx plus c, we have y equals negative 2x plus the positive 1 there for the y-intercept, and there's the equation of that line. And the last question on these, it says, here are the equations of 3 straight lines. It says 2 of them are parallel and explain which 2 are parallel. So in order for a line to be parallel, it's going in exactly the same direction and therefore it has exactly the same gradient. So in terms of the equation of a line, which we always want in this form, y equals mx plus c, we want to see this number being exactly the same. So these are all written in different formats. None of them are in the form y equals mx plus c. So we need to actually get them into that form y equals mx plus c. So let's have a look at this first one. And that says 2y. So in order to get that to be just y, we're going to have to divide everything by 2. So if we divide everything by 2, we get 1y equals 3x, I'm going to do 6 divided by 2, and then 5 divided by 2 is 2.5, or I could just leave it as a fraction if I want 5 over 2, which you can write as 2.5 if you like. So this line here has a gradient of 3. Let's have a look at the next one. Y plus 3x equals 5. Well, that's not in the y equals mx plus c format either, because this 3x is on the wrong side of the equal sign. So if we take away 3x from both sides, move that over to the other side, we get y equals negative 3x plus 5, just popping that plus sign in front of that 5 there. Again, we could have written it the other way around, but let's keep them all aligned. So that is a gradient of negative 3. So those two definitely aren't parallel. Let's just have a look at this last one. So 3x minus y equals 5. Now this isn't very nice because we've got a negative y here on the left hand side. So I might have to do 2 steps here because I'm going to add y to both sides to make sure that that's positive. So at the moment we have 3x equals y plus 5 or 5 plus y. Let's write y plus 5. And then again we need to get rid of this 5 now because we don't want that there, so we need to move this 5 to the other side. So take away 5 and we get 3x plus 5 equals y. Now it's written the other way around there, but we can rewrite that, we can swap the sides over. So y equals 3x plus 5 is our final answer for that one. And again this one has a gradient of 3. So the top equation and the bottom equation both have a gradient of 3. So explaining which two are parallel, we would say line 1 and 3, as they both have a gradient of 3. And there we go, both have a gradient of 3. And that's that one finished. Okay, and on to algebra. This is a bit of a long one. Let's have a look. So we've got triple brackets to start with. Now you can expand any two that you want to start with. I'm just going to go for the first two. So if we expand those to start with, let's have a look at what we get. So 2x plus 3 multiplied by x plus 4. Now if we expand that out, just following normal expansion rules, we get 2x squared plus 8x plus 3x plus 12 on that last bit there. Okay, tidying that up first. So tidy this up, simplify it down. We get 2x squared plus 11x plus 12. Now we can multiply it by the final bracket being up there, the 3x minus 1. So stick this in a bracket and multiply it by 3x minus 1. Again, just take your time with this, it does get quite messy when you're doing it. Okay, so just spend the time, make sure that you get each piece perfect. So let's move this out of the way. And let's just be really, really careful when we expand this now. So 2x squared times 3x gives you 6x cubed. And then 2x squared times minus 1 is minus 2x squared. Onto the 11x. Let's go for a different colour. So 11x times 3x is 33x, so positive 33x squared again. There we go. And then 11x times negative 1 is a negative 11x. 2 more to finish this off. 12 times 3x is 36x. Just about fit this in. And then 12 times minus 1 is minus 12. Right, there we go. We just need to tidy all this up now because we've got a lot of pieces there. We've got the 6x cubed at the start. We've got negative 2x squared add 33x squared. So negative 2 add 33 is 31. So plus 31x squared. Negative 11 add 36 is 25. So 25x squared. Sorry, 25x. And then the minus 12 at the end. And then do just go back, double check, make sure you've added up the pieces correctly. Just to make sure that you don't make any mistakes on that final part there. But that's expanding a triple bracket. Just remember to tidy up your first double bracket and then multiply it very carefully by the next one. Okay, so factorising a quadratic, and here we've got a coefficient bigger than 1 at the start. So we just need to have a think about how you do this. You can have 2, 3, 5, you can have any combination of numbers here. But in order to get a 2 at the start there, we're going to need 2x in one of our brackets and then x in the other. And then we'll just follow the same process, write down the factors of 12, so 1 and 12, 2 and 6, 3 and 4. And we've just got to think, okay, well, one of these numbers is going to double and we want to make negative 5. Obviously, this one has a negative 12 at the end, so one's going to be positive, one's going to be negative. And when one doubles, we're trying to make that number 5 in the middle. So it's not going to be 1 and 12, because we can't make 5, particularly if we double the 12. We're not going to make 5 if we've got a 24 and 1. And we're not going to make 5 out of 2 and 12, so it's not that one. Let's have a look at the next one. Doubling the 2 would make 4, so 4 and 6. Can't make 5 out of 4 and 6. Doubling the 6 would make 12, and you can't make 5 out of 2 and 12, so that's not going to work either. Let's try the 3 and 4. Double the 3 would be 6. We can't make 5 out of 6 and 4, so it's going to have to be this last one. Doubling the 4, which is going to make 8, so 3 and 8, and that works. You could do positive 3, take away 8, that would give us negative 5. So we want the 4 to double, so we stick that in the opposite bracket to the 2x. We want that one to be negative, so stick a negative with that, and stick your plus 3 in the other one, and there is your factorised double brackets. Just remember as well, it could say actually to solve something like this, and you can solve by factoring. If it did say the word solve, then we'd have two solutions here. For this right bracket, it's nice and easy, just flip the sign, we'd have x equals 4. And for this left bracket here, nice and easy again, it's still flip the sign, still 3, but because of this 2x here, it'd be minus 3 over 2, or minus 1.5. So if it did say solve, that'd be an additional step that you could go about. You could say x is negative 1.5 and x is 4. Okay. Okay, so we've got rearranging or making x a subject here, and we've got two x's in our formula. So, I mean, we can have so many combinations of this question that you can have. The whole idea of this type of question, though, is that you get the x's on the same side of the equal sign, everything else to the other side. Now, obviously, the x's are on the same side of the equal sign at the moment, but we want to get rid of this fraction. So you might not have a square root in a question, but in order to get rid of this square root to start with, we need to square both sides. So if we square both sides, we get y squared equals, and then what's left under the square root, it's not going to change that, we're just going to have x plus 3 over x minus p. Now again, we've still got a fraction involved, so we need to get rid of this denominator. So whatever's on the bottom there, we're just going to times both sides by what's on the bottom. I'm going to stick it in a bracket because it's easier for me to move it. So x minus p, and times the other side by x minus p. Okay, so we've got a bracket on the left, we've got y squared, brackets x minus p, equals x plus 3. Now, as soon as we've got rid of this bracket, we can start to actually move the pieces out of it. So if we expand the bracket, we get y squared x minus y squared p, or py squared, however you want to write it, and that equals x plus 3. Now I can start to move the pieces either side. So let's go for, there's two ways of doing this one. At the moment, I could move the x's to the left or the x's to the right. Now what I'm going to do is I'm going to move the x's to the left, so I can get rid of this negative y squared p or plus py squared. I'm going to rewrite it differently. So plus py squared to both sides. Let's bring this up here, and we get y squared x, or xy squared. Probably should have rewritten it there, it doesn't really matter. Add they over, so we get x plus 3 plus this new py squared over here. Now we can minus the x from both sides. We can get all our x's on the left, so minus x. So, and again, I will write this now. I'm going to write xy squared, I just prefer it. Xy squared minus x equals 3 plus py squared. And here's where this process starts to come in now. We can factorise this left-hand side so that we get 1x. So we'll get x brackets y squared minus 1. That equals 3 plus py squared. And then you can divide by this bracket here and slot it underneath the right-hand side. So you get x equals 3 plus py squared over y squared minus 1. And there would be our final answer. Obviously there is an unlimited amount of different formulas that you could have to rearrange. So I'm only going to go over the one here because it involved a lot of different steps there. Getting rid of a square root by squaring, getting rid of a denominator by timesing it across, putting it in a bracket in this second step. That was over here. And then we had obviously expanding a bracket, getting all the x's on the same side, factorising it to finish. I mean, you've got literally every possible step you could think of in this one. So it's quite a difficult one there, but there's just an example of some rearranging and what to do when there's two subjects that you're trying to turn into the one. Okay, so working out the nth term for this sequence. So whenever you're working out the nth term of a sequence, this is a quadratic one. It doesn't say it in the question, but it is a quadratic. You hopefully can see that just by looking at it, because here it goes up by 4, and here it goes up by 6, and then here it goes up by 8. Okay, so because of that, we've got a second difference here. So the second difference is 2. Now, whenever you get a second difference, what you need to do is actually divide that second difference by 2. It's just something which happens with the square numbers. If you think about the square numbers, and this is why it's a quadratic sequence, 1, 4, 9, 16, the second difference comes out as 2. Let's have a look. So 3, 5, 7. And the second difference is 2, and that tells you that it's related to the square numbers, but it can be more than just the square, like one lot of the square numbers. So if we divide this by 2, it tells us it's 1n squared, or it's related to the square number sequence, which is this one here, n squared equals 1, 4, 9, 16. So what I always do is write down the square numbers now. Again, I know there are formulas for this, but I just really prefer this method. So 1, 4, 9, 16. But now if you have a look, there is actually a difference between the n squared sequence and the one going up there in the question. To get from 1 to 15, let's just write this down. What's the difference? To get from 1 to 15, that's plus 14. To get from 4 to 19, that's plus 15. And to get from 9 up to 25, that's plus 16. And this just carries on. Look, from 16 to 33 is plus 17. So not very nice. Look, if we had a constant difference, if they are all plus 14, then you'd just put n squared plus 14. But unfortunately they're not, so we can't do that. They're not all just plus 14. So when you get this scenario here, you've got to have a look at this sequence and think, okay, well I'm going to have to just work out the nth term of that sequence. And the nth term of that sequence is, it goes up in ones. Look, 14, 15, 16, 17, it goes up in ones, so 1n, or n. And then it's obviously not the 1 times table, or if you know the little trick where you go back here, you take away 1, you'd get a 13 at the start. So it'd be plus 13, because it's 13 bigger than the 1 times table. So that sequence there has an nth term of n plus 13. So all you do is you just slot that at the end of n squared, so n squared plus n plus 13, and that would be your nth term of this quadratic sequence here. Okay, n squared plus n plus 13. You can get something slightly different here, like if you had a second difference of, if we just imagine this to the side, if you had a second difference of 4, so if it was 4, your sequence would start with 2n squared. And then you would have to write out double the square numbers. So instead of writing 1, 4, 9, 16, you would write 2, oh, what happened there? You would write 2, 8, 18, 32, and then you would compare the difference back to these numbers. Similarly, if it was 3n squared, if there was a second difference of 6, you would triple all the square numbers and compare it again. Obviously, just remember, if this comes out as a constant difference down here, that's great. You can just put that after the n squared part, or the 2n squared. But if it is a new sequence, you are going to have to forget about the rest of the question for a second and just work out the nth term of that sequence, and then slot that on the end. So our final answer there, n squared plus n plus 13. Okay, so this question says find the coordinates for the turning point of the graph with this equation. So to find the turning point, we have to do something called completing the square. And sometimes it might say write it in the form. It might say x plus a squared plus b. It might say write it in that form. Okay, and that just means completing the square, and it's how we find the turning point. So in order to do this, you have a look at the x coefficient, which is there, and we halve that number, and we stick it in the start of our bracket like this. So we have x plus 8 halved is 4 squared. And the reason you do that is because if we expand this bracket, and if we think about it to the side, if we expand that bracket there, x plus 4, x plus 4, x plus 4, there we go, we would get x squared plus 4x, which would give us 8x, but we would get plus 16 at the end. So obviously it's similar to this part just here. We've still got the x squared, we've still got the 8x, but we've got plus 16. And we don't want plus 16, we want plus 3, because all we're doing is we're rewriting it as in a different form, in this completed square form. So in order to make sure 16 becomes 3, we would have to subtract 13 from this double bracket there. 16 take away 13 give us 3. So that is actually written in completed square form there, and that is how you do it. Now you don't have to fully expand the double bracket. You can just think, okay, well 4 times 4 is 16. That's the number I know I'm going to get at the end. So I'm going to have to take away 13. And our coordinates for the turning point are written within this. So the x coordinates in the bracket there, just like when you're solving, you flip the sign. So the x coordinate is negative 4 instead of positive 4. And the y coordinate here is just this number at the end. No flipping of the sign, just writing whatever's there, so minus 13. There you go, so the coordinate of our turning point is negative 4 and negative 13 for the y coordinate. And that's completing the square. Okay, a longer question here, we've got to solve the simultaneous equations. Now when we've got an x squared and a y squared, this actually represents the equation of a circle. and the equation of a line. Okay, and that line would be, go sloping this way I believe, let's have a look. Okay, so when you get this sort of scenario here, you get two solutions because there's two crossover points. There is one scenario where you might get one solution, which is where it's a tangent to the circle if it just touches at one point. There could even be no solutions, but it would be unlikely we'd be asked to try and solve something with no solutions. So if we have a look at this, we've just got to basically sub one into the other, and we can sub this x minus y equals 2 into the equation of above. So if we actually do that, first of all we've got to rearrange it. Now there's two ways. I could make y the subject or x the subject. So I'm going to make y the subject, so I'm going to add y to both sides, which actually that would straight away make x the subject, so let's do that. X equals 2 plus y. Okay, you could even write that as y plus 2 if you prefer, and I'm actually going to do that, x equals y plus 2. Now what we can do is we can sub this little expression here, y plus 2, in place of the x in the first equation, this x squared. So if I just do that, so rather than writing x, I'm going to write y plus 2. So y plus 2 squared plus y squared equals 34. Right, so we've now got an equation that has no x's in, and we know that when we've got an equation that only has one unknown in it, we can definitely solve it. So if we actually go about expanding this first bracket here, I'm not going to write it as a double bracket, I'm just going to go for it. So y squared, we'll get plus 2y, so plus 4y, and plus 4 at the end. And then obviously we've got plus y squared equals 34. Now we can tidy that up, look, because we've got these two y squared pieces. So we can add those together just to make it a bit more tidy. So we've got 2y squared plus 4y plus 4 equals 34. And now we can only actually solve one of these, it's a quadratic, so we can only solve that once it equals 0 at the end, so we need to minus 34 from both sides. So if we minus 34, we get 2y squared plus 4y, and 4 minus 34 is minus 30, and that now equals 0. So we can actually go about solving this now. Now, if in this point here, if we've got a calculator, we could potentially use the quadratic formula, we could factorise it from here, but if you notice that all these numbers here all divide by something, we can simplify it down, because we can divide both sides by anything as the right hand side is just 0, it doesn't change it. So if we divide everything by 2, we get y squared plus 2y minus 15 equals 0, and it potentially just makes it a little bit easier to factorise there. Now if we go about actually factorising this, both are going to have a y in, and we're just thinking what numbers there multiply to make 15. So we've got 3 and 5, or 1 and 15. I'm not going to write down the 1 and 15 because I've already spotted it's 3 and 5. And in order to make 2, we need plus 5 minus 3, and that's going to give us positive 2 in the middle. So we've got two solutions going on here. Obviously it's just these numbers in the brackets, but flip the symbols. So we've got y equals negative 5, and we've also got y, I'm just about to write x there, y equals 3. So there's our two y solutions. We now just need to find our x solutions. Now we've got a nice little formula that we made right at the start here. To find x, we've got x equals y plus 2. So when y is 5, x will equal negative 5 add 2, which is negative 3. So x equals negative 3. And then for the next one, we've got y equals 3, so x equals 3 plus 2, so x equals 5. There you go, so you've got your two solutions and they're written in pairs there. We've got our first solution here, x equals negative 3, y equals negative 5. And we've got our second solution over here, x equals 5 and y equals 3. Okay, so there would be coordinates there. So it might be, if we think back to this graph, it might be that this coordinate where it crosses over is negative 3, negative 5. And this coordinate up here is 3, 5. Okay, so that's what it represents there when we're solving these simultaneous equations. And remember, that could be solved graphically as well. You might be given a diagram, drawing on a straight line and then just, estimating them or finding them exactly where they cross over. Okay, so there's solving simultaneous equations, and again, there's loads of different variants here. You might have two that have y squared in or y in, and you can set them equal to each other, but this is just one of the harder ones here where you've got to sub one into the other. Okay, so we've got some quadratic inequalities. So we're going to solve this. Now obviously these represent a parabola, a curve, a quadratic graph. Again, a quadratic graph here. Normally when we're solving them, we are solving to find these two roots here, or solutions, and you can be asked to represent to find them or to estimate them from a graph. If you've been given a picture, they're referred to as the roots. But when we're solving an inequality, we're looking at something slightly different. Now this first one here, and they're both exactly the same. We're going to have a look at the two different scenarios. This first one says less than 0. So essentially it's saying is what part of this curve is less than 0. Now if you have a look, this part of the curve is what's below ground, what I like to refer to, or less than 0, 0 being the x-axis there. So really all we're going to say is, well, what part of the curve is between these 2 points below 0? So if we actually just factorise this to find out what these two roots are, so putting it into a double bracket, again it might have a coefficient bigger than 0, but I'm just going for a nice easy one here just to show you the process. So the factors are 24, we can have 4 and 6, 2 and 12, 3 and 8, so I'm just going to not write them all down because I've already spotted it's 3 and 8. But that would be plus 3 minus 8, and that would give us minus 5. So our roots here, our solutions are x is negative 3 and x equals 8. So if we were to label those on the graph here, this would be minus 3 on the x-axis and this would be 8. Now the bit that is below the curve is between negative 3 and 8. So I'd have to write this as one of these types of inequalities. Okay, where we say it's between 2 points. And that would be my answer there. X is between negative 3 and 8, or the part of the graph that is under 0 or less than 0 is between those two numbers. Now that would change slightly for this one down the bottom, because I've just realised they're pointing the same way. That wasn't meant to be pointing that way. Let's change that. That's meant to say bigger than 0. Okay, so there we go. Sorry about that. Let's change that. X squared minus 5x minus 24 is bigger than 0. So this would be something slightly different now, because the bit that's bigger than 0, and if I just redraw this graph, there we go, 8 here, negative 3 here. The bit that's actually bigger than 0, we've got one part over here, and we've got a completely separate part over here. So we've got two separate parts of the line, and that means I can only write this as two separate inequalities. Now this part on the left is all this part of the curve is going to numbers less than 3. So my solutions there would be, well, anything that's less than 3. Sorry, negative 3. So x is less than negative 3. And that's one of my solutions for that part of the line. But I've also got the other part, and that is going to all the numbers bigger than 8. It's going this way. So my other solution would be x has also got to be bigger than 8. So I've got two solutions here to write with my inequalities. I've got all the x values less than negative 3 and all the x values bigger than 8. So that's solving a quadratic inequality. Just got to think about which part of the graph you're actually looking at. Okay, and we've got a question here that's shade the region that satisfies all of these inequalities, and we've got these three inequalities there. Now some of these are quite easy to draw, but when we're drawing these inequalities, if we just imagine us to start with that the inequality is an equal sign, it's just going to help us to actually draw the graph. So all I'm going to do is I'm just going to imagine that this one says y equals 2x plus 1. I'm going to draw that line. X plus y equals 4. I'm going to draw that line, and I'm going to draw the line y equals 1. Now the easiest one for us to draw there is y equals 1. Now looking at my graph here, you can't see the number 1, but it's between 0 and 2. Now on the y-axis, y equals 1 is at this point here, and that line y equals 1 is just a nice straight line going through y equals 1. So that's our first one drawn there. Done. The next one is x plus y equals 4. I'm going upwards now, so x plus y equals 4. Well, if x plus y equals 4, that's quite a nice line to draw, because that means when one coordinate's 0, the other has to be 4. So 0 on the x-axis gives us 4 on the y-axis, and 0 on the y-axis gives us 4 on the x-axis. So you've got a nice diagonal line there to draw between 4 on both the axes, and these x plus y equals a number always just connects up the y-axis and the x-axis to those numbers. So we've just got to do a nice neat diagonal going through with a ruler and a pencil, and I'll continue that all the way. Oh, that's not very good. I'll continue that all the way to the top of the graph there, just a nice diagonal going all the way through. So that's that one done. And the next one there is y equals 2x plus 1. Now you might know little tricks for how to plot these. If not, then I would suggest just drawing yourself a little table and picking some of the values. You probably get away with doing 2 or 3 values. But if we sub in some x values to find our y coordinates here, when x is 0, that would be 2 lots of 0, add 1, y is 1. So if I do this in a different colour, so when x is 0, y is 1, that gives us that coordinate there. Let's pick 2 or 3, let's just go a little bit higher. So when x is 2, 2 times 2 is 4, plus 1 is 5. So when x is 2, y is 5, and that is here. And we could go for some negative numbers as well now, but hopefully you can get a ruler and a pencil and join those up. Now it has a gradient of 2, so I can just look at that coordinate on the y-axis there and go across 1 up 2, which gives us that coordinate there. Cross 1 up 2 gives us the one we've already drawn, and I can follow that pattern backwards as well. But you can draw a full table out for this just to make sure you get it perfect. But there we go, there's my line. I just need to connect those all together nice and carefully with a ruler and a pencil. And there's our 3 lines drawn. Okay, now it says shade the region that satisfies all these inequalities. Now careful, because it's not always that little triangle there that's made in the middle. So I'm going to get rid of these equations now, so I don't need them anymore, but I need to have a look at the inequalities. Now all I need to do is pick a coordinate and test it in these inequalities. So if we do pick this one in the triangle here, so this coordinate here, let's do it in a different colour. There's a coordinate inside the little triangle in the middle, which is the coordinate 1, 2. This coordinate here, well, x is 1 and y is 2. And if I sub them into these inequalities, as long as they all work, then that's the region I'm going to shade. So if I sub it into that first one there, x is 1 and y is 2, so y is, which is 2, is less than 2 lots of 1, which is 2, plus 1, so 2 is less than 3, and that works, that's correct. Moving on to the next one then, that one works, we've got to test all 3 though. X plus y is bigger than 4, so x is 1, so 1 plus y, 1 plus 2 is bigger than 4. No, that doesn't work. So it can't be inside that triangle there. Although what we have figured out is that the first one works. So in terms of that line, y is less than 2x plus 1 is my pinky red coloured line there. So it's got to be on the right hand side of that. So it can't be this region on the left, it can't be this region on the left, and it can't be this region on the left. So it's got to be one of the other 4. But it's not inside that triangle now, so we can put a cross in there as well. We know it's not that one. So we've got 3 left to have a look at. So if we get rid of this, and obviously always leave your working out down, but let's try another coordinate. So let's try one in this region here, as this one's on the top. So that coordinate there is the coordinate 4, 3. Okay, so this one here, 4 and 3. And if we test those out into all our inequalities and see if they actually work. So looking at the first one, we've got y is 3, so 3 is less than 2 lots of x, so 2 lots of 4, 8 plus 1. So 3 is less than 9, and that's correct, that works. Moving on to this x plus y is bigger than 4, so x is 3, so 3 plus 4 is bigger than 4. Well, that's absolutely correct. 7 is definitely bigger than 4, so it works in that one as well. And then on to the last one here, y is bigger than 3. Sorry, y is bigger than 1. The value of y is 3 there on that coordinate, so 3 is bigger than 1. Perfect, they all work. So it's got to be that region there. So we just have to shade this region in. It might say to label it R or something like that, but shade it in and there's your region done. So once you've drawn your lines, just pick a coordinate, test it out into your inequalities, and as long as they all work and they're all correct, then you can shade that region. But do be careful you don't just shade the region of the shape there, like the triangle in the middle, because it's very often not just the shape that's formed. Okay, so we've got solving a quadratic here, and it says give your answer correct to 3 significant figures. Now this gives you a massive hint here, 3 significant figures that it doesn't factorise. And when a quadratic doesn't factorise, when we've got to solve it, in whatever scenario, we've got to use the quadratic formula. So one that you need to remember, you've got minus b, plus and minus the square root of b squared minus 4ac, all over 2a. And then what I do straight away is I write down the values of a, b and c. So a is 5, the one in front of x squared. So a equals 5. We've got b equals, and you've got to be careful because you've got to get the symbols in, the signs in with it, negative 11. So b is negative 11. And c is, again, that number at the end, negative 13. So first things first, we just need to put them all in the right place. So minus b will be, well, negative b. And b is already negative, so that becomes positive. So b is 11. Plus and minus the square root of b squared, and we're squaring a number here, and it's negative, so stick it in a bracket. Minus 11 squared, take away 4 times 5 times negative 13, 4 times a times c. So 4 times 5 times negative 13. There we go, and you can stick that all in a bracket if you want, just depends on what calculator you're using. And that's all over 2a, which is 2 times 5, which is 10. Let's just write 2 times 5. Now if you've got a Casio calculator, which hopefully you do because they are the best ones for these higher GCSEs, then you need to just type that in as you see it. So press your fraction button, 11. Let's do plus. I'm going to do the plus version first. So I'm just going to do it once using the plus sign here, and then I'll do it again in a different colour using the negative. So 11 plus the square root of, in brackets, minus 11 close brackets squared, take away, in brackets 4 times 5 times negative 13, go on to the bottom of the fraction, and I'm just going to type in 10. And when I type that in, turn it back into a decimal, it says I get 1 which is 3.05192213, and then I'm just going to go back into my calculator, change the plus sign for the minus sign, we'll write down what we get there. So back into the calculator, takes a bit of a while to get all the way back through this, but it's better than typing it all back in again. Delete the plus, put a minus, press equals again, and I get the answer negative 0.8519221296. There we go, lots of digits there. So obviously there are two solutions, one with a positive there, one with a negative. Then we've just got to round it, so it says 3 significant figures. So in the first one there, 3, 0 and 5 are my first 3 significant figures. So that would be 3.05 for my first solution. And the second one's a little bit iffy here because we've got a 0 at the start, so it's 1, 2, 3 after the 1. So that would be 0.852 because it's a 9 after it. There you go, and there's my 2 solutions written to 3 significant figures. Just be very, very careful when you're doing the quadratic formula that you do make sure of a couple of things. That is, one, when b is negative, make sure it flips this sign for the first one, and the second one is make sure you put these negative numbers in a bracket. Otherwise, it's gonna give you an answer of negative 121 there rather than the positive 121. Although if you are squaring a negative number, you could just put 11 squared and forget about the negative, but a little bit of a trick there. Okay, there we go. On to the next one. Whenever we get an algebraic fraction, though, we just need to factorise everything that we see, no matter what the question, whether you're times and dividing, it's just simplifying, just factorise everything. And that can be quadratics with coefficients bigger than 1, we can have difference of 2 squares, we can have single brackets, but just look and see what can I do to factorise it. So the top there, there's no number at the end, so it definitely doesn't go into a double bracket, but the top, the 3x squared and the 9x both divide by 3 and they both have an x in, so we can simplify it, we can factorise it that way. So 3x times x gives us a 3x squared, and 3x times 3 gives us that 9x there. So that's that factorised on the top. Now if we have a look at the bottom, that has a number at the end but no x pieces in the middle, so that's a difference of 2 squares. The factors are 9, it's the 3 and 3, one positive, one negative, that's what cancels it out. So we have x plus 3 and x minus 3. There we go, and when we've got these common brackets on the top and bottom, we can cancel them out. So the x plus 3 and the x plus 3, we can divide the top and bottom by x plus 3. So we end up with a final answer of 3x over x minus 3. And again, you can have lots of different scenarios where you're simplifying an algebraic fraction. Again, there could be different sorts of quadratics or just single bracket factorising that you're doing. But there is the idea of how you simplify these. And no matter what question you see an algebraic fraction, you're normally always looking to factorise. So look at one more. Okay, so we've got some more algebraic fractions here. Now we're adding these together, so we need a common denominator. So I've got to solve an equation here, but I've got to get these algebraic fractions added together first before I can do that. So if we times both sides, or this left-hand fraction, top and bottom, by x plus 1, and also times the top by x plus 1, that's going to allow me to get a common denominator as long as I times the right by the left denominator as well, which is 3x minus 2, just following normal fraction rules there. So times that by 3x minus 2. Okay, and I've written that next to the top and bottom so I don't forget what I'm timesing by. So on the top there we get 8 lots of x plus 1, and we're going to add to that 6 lots of 3x minus 2. Now because I'm going to get a common denominator here, I'm just going to write that all over my double bracket, which is x plus 1 and 3x minus 2. There we go. Now we can go about expanding all of that and just get it all tidied up. So if I expand the top, we get 8x plus 8. And then we get plus 18x minus 12. And that's going to be all over this double bracket expanded. So x times 3x is 3x squared. I'm going to skip a step here. I'm going to do the minus 2x plus the 3x. Minus 2 plus 3 gives me plus x. And then minus 2 at the end. There we go, that all equals 2. Before I set it equal to 2, I'm just going to tidy up what's on the top there. We've got 8x and 18x, which is 26x. And plus 8 minus 12, which is minus 4. And that's all over 3x squared plus x minus 2. So now I've got a single fraction with a common denominator, and that equals 2. Now we can go about actually getting this into a single line equation and removing this denominator. So I'm going to times both sides by this denominator here. I'm going to times that over, and that's going to put it next to this 2. So it's going to be 2 lots of 3x squared plus x minus 2. So if I rewrite this now as a single line, let's bring it up here, we get 26x minus 4 equaling, and let's expand this bracket here, 6x squared plus 2x minus 4. And if we rearrange this, I'm going to make it equal 0 on the left, so I'm going to minus 26x, and I'm going to add 4 to both sides. So I'm going to minus 26x and add 4, and that's going to allow me to get 0 over here. Obviously it's a quadratic and we need it to equal 0. It doesn't matter whether it's on the left and right, but I want to avoid having a negative 6x squared and having an extra step there. So 0 equals 6x squared. Take away the 26x from 2 gives us negative 24x. And then add 4 to that minus 4 gives us 0. So there we go, it doesn't have a number at the end. So we can actually solve this now. So I can solve this, but it doesn't have a number at the end, so it's not going to go into a double bracket, which it might do if it has a number at the end. So we might have two solutions like in that way, but I'm going to see what solutions I get this way. So if we factorise this to start with, I could actually simplify it. I could divide both sides by 6. And if I do that, let's see what we get. Divide both sides by 6, and we get 0 equals x squared minus 4 x. There we go. Now I can factorise it as well. I've just saved myself a bit of time there. So if I factorise it, we get 0 equals x brackets x minus 4. There we go. So now it's factorised. Hopefully remember as well, we've done this on a couple of other questions. This x value here has no number with it, so one of our solutions is x equals 0, and this one here we flip the sign, so x equals positive 4. And there's my two solutions, x is 0 and x is 4. And there we go, that's that solved. Obviously lots of different algebraic fractions that you could have. You could be timesing and dividing them, adding or subtracting them, solving with them. Okay, always just look to follow normal fraction rules, and obviously looking to factorise where possible in these questions. Okay, so we've got a functions question. So we've got f of x is 2x minus 4 and g of x is x squared plus 5. Now the first one we're going to have a look at is this here, so working out an inverse function. So an inverse function just means basically doing it in reverse. So the function of f is 2x minus 4. It times this number by 2 and then takes away 4. There's a nice way of doing this algebraically. We can change that f of x piece there for a letter. I'm going to just change it for the letter y. So y equals 2x minus 4. And I'm just going to rearrange it to make x a subject, which is hopefully quite nice and easy in comparison to the one we looked at earlier. So add 4 to both sides. You get y plus 4 equals 2x. And then divide both sides by 2. You get y plus 4 over 2 equals x. There we go. I'm just going to rewrite that with x instead of y, and that'll be the reverse function there, the inverse function. So instead of being y plus 4, it's x plus 4, so x plus 4 over 2, and that equals the inverse function of f, so f minus 1 x. There you go, and that's how you do your inverse function. And that can be done for any type of function here. Just swap the x and y, rearrange it to make x a subject, and then rewrite it. Okay, on to the next one. It says work out g(f(x). So you could be asked to put a number in. This isn't actually asking us to put a number in. It's saying g(f(x), which means I have to sub one of the functions into the other. So if you read this, it means what is the function of g when you put f into it? So what is g when you put f into it? So, well, g's up here. So all we've got to do is put f into it. So if I stick f into there, and the way that I do it is I stick the function of f in a bracket, and I'm just going to replace the x value here with that bracket. And if I do that, I get 2x minus 4 in brackets squared, because it's x squared, and then plus 5. So really there is an expression for that, but I'm going to completely expand it and simplify it all down. So we have a double bracket, we have 2x minus 4, and another 2x minus 4. And then once we've expanded that, we just need to remember to add 5. So if we expand that, and again, I'm going to skip some steps here. I'm going to do 2x times 2x, which is 4x squared. And then we've got 2x times minus 4 and 2x times minus 4 again. So minus 8x is minus 16x. And then 4 times 4 gives us 16, but we're going to add 5 to that. So that'll give us 21, so plus 21. And there's your expression for that. You could have had this written in a different way. You could have had f gx, and in that case you'd do it the other way round. It says what's the function of f when you put g into it, so you put your bracket round g and slot it into the x place in f. So you can have two different ones there as well. Just got to make sure that you do them in the right order. You could also be asked to sub a number in, so it might say something along the lines of f, let's do it the other way round, fg, I don't know, 2. And in that case that means what's f when g is 2? So you put 2 into g, and if you put 2 into g you get 2 squared plus 5, which is 9. And then you put 9 into f. So what is f when g is 2? Well, when g is 2, we get the answer 9. So you stick 9 into f. So putting 9 into f, which is our first function there, you do 2 times 9, or 2 lots of 9, take away 4. 2 lots of 9 is 18, take away 4 is 14, so that would be our answer there if it asked us to sub a number in. But these ones are a bit harder when you have to put a function in and remember what order to do it in. But just remember the way you read it. So for this one we looked at, what is g when you put the f function in? And there's some functions for you. Okay, so looking at some iterations. Now this says using x to the n plus 1 equals 5 over xn squared plus 2, and then it gives us x naught equals negative 2.5, find the values of x1, x2, x3. So all this is a process to finding estimates to a solution of an equation. Now the equation is not given to you in this one, but it does give us this iteration formula. Now this little n plus 1 here just means to find the next estimate. So if you read that in words, it says to find the next estimate, you do 5 divided by, and this little xn here means the current estimate, so the current estimated solution squared, plus 2. And then it says with x naught equals 0, and x naught just means your starting number, and it says start with negative 2.5. This is quite nice and easy actually when you do these. All you've got to do is sub that number into the equation. So don't be put off by the language here. That just means to find the next number. So to find the next number, all we're going to do is in our calculator we're going to do 5 divided by, and this will give us x1, our first solution, that's what x1 is. 5 divided by the current number squared, so negative 2.5 squared. And again, you've got to be super careful here because you've got to put this in a bracket. So the current number squared, so remember when we're putting a negative number in, we want to put it in a bracket. And then plus 2. So to find the current number, to find the current solution, or the next solution, you do 5 divided by our starting number squared and add 2. So literally just typing that into your calculator. So open up your fraction button, make it look exactly the same as that, 5 on the top, negative 2.5 on the bottom squared, and then come out of your fraction and plus 2, or press equals and then add 2. Now you get a decimal for this, you get either a fraction, 14 over 5, or 2.8. So there is our value of x1. Now obviously that is our current solution, so 2.8 is our new number. So I'm going to repeat the process here, but instead of putting negative 2.5 in, I'm going to put this 2.8 in. So where I put it in here, that number is now just going to be 2.8. And it's quite a nice little trick you can do on the calculator here. As long as you don't press equals, you can do 5 over, and you can either type this number in, 2.8 squared, or you can just press your answer button. So there's an answer button next to your equal sign, usually just says ANS, and you can just put the answer in there. And it's a lot quicker if we have to do lots of solutions here, but for this one it's quite nice and easy for me to type it in, so I'm just going to write it. There we go. So you go back on your calculator into your formula, make sure you haven't deleted anything, press your answer button, and it'll put 2.8 in for you. Press equals again, and again this is where the answer button comes in, because the number that we get here is absolutely horrible, and I'm going to have to write it all down. So it gives me the answer 2.637755,102, and that is my value of x2. Now I don't really want to write that in over and over again. You can do as long as you've written it all down, but because I can use this answer button now, I'm just going to not touch my calculator screen at all, and I'm just going to write down what x3 is. So on my calculator screen it currently says 5 over answer squared plus 2. So all I'm going to do is just very carefully, making sure you haven't deleted anything off your calculator, I'm just going to press equals again, and it gives me my next answer. It subs that 2.63 number in for me, and I get the answer 2.718622914, and it doesn't say to round them, so I write down all the numbers on my calculator display, and there they are. There's the values of x1, x2 and x3. Basically just subbing a number in, getting an answer, and then subbing your answer back in. So remember, these are estimates to the solutions of a particular equation. Now the equation wasn't given to us, but these are the estimates to the solution of that equation. Okay, so that's what we use iteration for, and there's your iteration. Okay, so we've got, and I can just see down here, we've got some graph transformations. So it says the coordinates of the minimum point of a curve are 3 and -5. Now there would be an equation for this curve, but it's not written down on this question. Okay, and it says write down the coordinates of the minimum point with these equations. So given that that curve there has an equation, what we're going to do to the function over here. So there's a few rules to remember with this one. If the number in these functions over here is next to the x, or whether it is outside of the x, and it's next to the y, let's say, there we go. So if it's next to the x, it does the opposite of what you'd expect it to do. We'll talk about that in a sec. Okay, and if it's next to the y, it does what you expect. We'll talk about what you'd expect in a second. Okay, if it's next to the x, it affects the x coordinate, and if it's next to the y, it affects the y coordinate. Well, let's have a look at this to start with then. So part A there, we've got a +2 next to the x. So it's going to affect the x coordinate, but it's going to do the opposite of what we'd expect. Now we would expect a +2 to add 2 to the x coordinate, but because it's in the bracket there, just like when you can sort of almost link this back to when we're solving and factorising, and when you get a bracket and you flip the symbol, it does the opposite. We can kind of almost link it to that, but what it does is it actually takes 2 away from the x coordinate. So that's going to mean it's going to be not 3, but 1. So 1 minus 5. There you go. Does the opposite of what you'd expect. We take away 2 from the x coordinate. Now on to the next one, and this is where this kind of has a little bit of difference going on. We've got a minus there. Now it's not next to the x coordinate, so we say it's next to the y. So as it's not next to the x coordinate inside the bracket, it affects the y coordinate. But a negative symbol there just flips the sign in front of the number. It doesn't do the opposite or not do the opposite of what you'd expect with a negative symbol. It literally just changes it from negative to positive or positive to negative. So it doesn't affect the x coordinate because it's not in the x bracket. So it stays as a 3, but the y coordinate goes to +5. There you go. So it changes it from -5 to +5. Okay, so the negative could be inside the bracket. If it was, it would change the symbol on the x coordinate instead. Look at the next one here. We've got a -3 at the end. Now it's not inside the bracket, so it does what you expect. And we would expect -3 to subtract 3 from the y coordinate. So it doesn't affect the x coordinate, but it does subtract 3 from the y coordinate. So -5 would go down to -8. There we go. Every time I'm just referring back to this coordinate here. And on to the last one. We've got 2x in the bracket. Okay, for this one, so it does affect x because it's inside the bracket next to the x, but that means it does the opposite of what you'd expect, and that means 2 times x, so you would expect that to double the x coordinate, but if it does the opposite, it halves the x coordinate. That's the opposite of timesing by 2 is dividing by 2. So instead of it being 3, it would be 1.5, and it doesn't affect the y coordinate, so it would be -5. There you go. So obviously lots of different variations of this. You could be asked to draw the graph as well, but you can always just take this approach, pick a coordinate on the graph and see how it actually changes the coordinate. So it might be that you actually have to move it right, move it left, move it up or down, stretch it or reflect it with one of these negative parts outside or inside the bracket. Okay, but always just remember these little rules. So if it is in the bracket next to x, it does the opposite of what you'd expect and affects the x coordinate. And if it's outside of the bracket, which I've put next to y there, it does exactly what you'd expect, but it affects the y coordinate. Okay, so obviously different variations of these if we change our pluses and minuses. On to some algebraic proof. It says prove that the sum of the squares of 2 consecutive odd numbers is always 2 more than a multiple of 8. Now there's loads of different questions on algebraic proof, and again I'll have a video with lots of these different examples, but here's just quite a good one here. So it says prove that the sum of the squares of 2 consecutive odd numbers. So there's a few numbers that you need to know. So any number we refer to as n. An even number, well, an even number, if you get any number and times it by 2, it becomes even. So an even number in this proof is we're going to say is 2n. Now to make a number odd, we can just think, well, okay, well, times it by 2 makes it even, and then add 1 to it. So an odd number is 2n plus 1. Okay, so times any number by 2, you get an even number, add 1 to it, and it becomes odd. So 2n plus 1 is our little expression we're going to use for an odd number. But it says the sum of the squares. So that means add them together and once they've been squared, and it's 2 consecutive odd numbers. Well, I've got one odd number there, 2n plus 1, so my next odd number would be 2n plus 3. Okay, to get to the next odd number we'd add another 2 to it, so it'd be plus 3 instead. So the numbers that I've got 2n plus 1 and I've got 2n plus 3. And it says the sum of the squares, which means we've got to square them. So I'll square them both. And the sum means to add, so we're going to add them both together. And again, lots of different variations we could have here, but we've just got to square these. So if I square this first one, that's a double bracket, remember, so we'd get 4n squared plus, we'd get 2n and 2n, so 4n plus 1. And for the one on the right here, we'd get 4n squared again, but it'd be plus 6n plus 6n, so it'd be plus 12n. and then 3 times 3 is 9, so plus 9. Right, let's have a look what happens when we tidy this all up. So adding together the 4n squareds gives us 8n squared, 4n plus 12n is 16n, and then 1 plus 9 is 10. Now what I could do at this point is, if it had said prove that it's always even, or prove that it's a multiple of 2, I could just factorise it by 2, and that would show that any number that I sub in there would be multiplied by 2, but it doesn't say that. It says it's always 2 more than a multiple of 8. So I'm looking to try and factorise this by 8. And if you have a look, well, the first piece divides by 8, doesn't it? I can do that. Let's have a look. Divide that by 8, or factorise it by 8, we get n squared. The next one, we can divide by 8 as well. We get 2n. 16 divided by 8 is 2. But I can't divide this last piece by 8. 8 does fit in once though, doesn't it? But it leaves us a remainder. And my remainder would be 2. So if I think about that over here, if I split this number up, and you can do it like this or think of it as a remainder, but if I was to write plus 8 plus 2 instead of plus 10, the 8 would divide by 8, giving me this plus 1, and then I would still have this plus 2 at the end that I've not factorised. And that there proves that. It proves that it's always 2 more than a multiple of 8. If we subbed any number into this bracket here, so any number, it would be multiplied by 8, and then at the very end we would add 2. So that there proves it. Okay, we would multiply everything by 8, meaning it's a multiple of 8. That means multiplied by 8. And then at the end we would add 2. So that proves that any number we sub in there into this expression is always going to be 2 more than a multiple of 8, because we times by 8 and then add 2 at the end. And that's the end of that one there. Again, lots of examples on this that I've got a good video on. On some coordinate geometry, we've got a straight line passes through the coordinates 0, 1 and 10, 6. Find the equation of the line perpendicular to AB that passes through B. So in order to find a perpendicular line, we need to find what the gradient is first. So if I have a look at A and B, we've got 0, 1 and 10, 6. So to find the gradient, we can do the change in y over the change in x, which you might also refer to as rise over run. So the change in y goes from 1 to 6. So the change in y there is 5, from 1 to 6. The change in x is from 0 to 10. So from 0 to 10, that's 10. And if we simplify that, that gives us a half. And I always leave these gradients in fractional form rather than as a decimal. So the gradient is a half, and I always write m equals a half, because we know we're looking at line equations, which is your y equals mx plus c. So m is a half. It says find the equation of the line perpendicular to that passes through B. So we're using this equation. So a perpendicular line, we do the negative reciprocal. So to get my perpendicular line, which I'll call MP, you flip the fraction over to get the reciprocal, so 2 over 1, and you change the sign, so it's negative 2 over 1. And negative 2 divided by 1 is just negative 2. So the gradient that we're looking at here is negative 2. So what I'm going to do is I'm going to write out what the equation of a line always looks like, which is y equals mx plus c. And I'm going to plug this piece into the equation of my line, because I've now got the gradient. So we've got y equals negative 2x plus c. Now it says it's got to pass through that point 10, 6. So if it's got to pass through 10, 6, I'm just going to stick these numbers in, remembering that we have an x coordinate here and a y coordinate here. So if I stick those in, we have y is 6, so 6 equals negative 2 multiplied by the x coordinate, 10, plus c. Now we just need to solve this for c. So we have 6 equals, multiply these, negative 20 plus c. Add the 20 over, and you get 26 equals c. So you found your y-intercept there. All you've got to do is finish this question off, put all the pieces back together. So you have y equals minus 2x, which we have already had up here, but now we've got c, and that's positive 26, so plus 26. So y equals negative 2x plus 26. Again, you could rewrite that in another way. You could write y equals 26 minus 2x. I'm just going to leave it like that because it's fine to write either way. And there's the equation of that perpendicular line. Okay, and the last one here, we've got a circle A has the centre 2, 5, and the point P, 11, 8, lies on the circumference of the circle. Find the equation of the tangent to the circle. Now what we know about tangents is they are perpendicular to the radius, okay? So a tangent is perpendicular to the radius. Let's think about that. Perpendicular to radius. Now it can help with these types of questions to draw a little bit of a diagram, just have a think about what this actually might look like. So if I have a think, a bit of an axis here, it says the centre's at 2, 8, so So I'll draw a little sketch, not the best sketch here, but 2, 8. And it says the circle, point P is 11, 8. Let's imagine that's over here somewhere. So we've got a tangent coming off the circle, and that's what it looks like. So there's a few, that's a really bad centre there. Let's change that. It's a little bit better. There we go. So this is a really, really general sketch of what it might look like. Okay, and it says that the point, the centre has a coordinate 2, 5, which is there, and point P is up here, 11, 8. There's lots of information we can find on this question here, but let's just have a look and just see what it's actually asking. It says find the equation of the tangent. So in order to get the equation of the tangent, I need to know what the gradient of it is. If we think about the radius here, okay, bearing in mind that they're perpendicular, that's what we've already stated, it forms the right angle. Could we find the gradient of the radius? Now we've got these 2 points, so we've got 2, 5, and that definitely attaches to 11, 8, which is on the circumference. So I can find the gradient of those points. I can do the same as we did in the last question. I can do the change in y over the change in x. And that's change in y goes from 5 to 8, which is 3, and the change in x goes from 2 to 11, which is 9. So my gradient is a third. There we go. So my gradient, or m, is a third. So looking at the tangent, which is perpendicular, I can say that the gradient of that is, well, flip it over, would give us 3, change the sign, -3. So there's the gradient of the tangent. So if we stick that into our line equation, as the tangent is a straight line, we get y equals -3x plus c. And we know that it passes through this point 11, 8. Okay, otherwise it wouldn't be on the circumference of the circle there, which it says it is. That's where the tangent meets it. So what I'm going to do is I'm going to stick 11, 8 into the equation of the line, just like I did on the last question. So we get 8 as y equals -3 multiplied by 11 plus c. And again, exactly the same as the last question, we can solve this now. So 8 equals -33 plus c, times in those out, add the 33 over, 41 equals c. So now I've got the y-intercept of that line as well. Now if we put this all together, we've got our equation. So y equals -3x plus 41. There we go. And there's the equation of the tangent. A few other things that you could be asked about this question though. Let's have a look. There we go. You could be asked to work out maybe the length of the radius. So if we go back to our diagram over here, in order to get the length of the radius, we'd have to use a little bit of Pythagoras. So bringing that down there, you've got a little right angled triangle you can draw in, and it goes from 2 to 11, which was a run of 9 there, and a rise of 3, so you could do 3 squared plus 9 squared, so you could actually get the length of the radius there. What would that be? 3 squared is 9, 9 squared is 81, so square root of that is root 90. So you don't need it for this question, but you could say the radius is root 90. You could also be asked to write down maybe the equation of the circle or something like that, but just something else to be thinking about if you ever want to find the length of the radius. You can find it by using a bit of Pythagoras there. Not that we needed it for this question though. Right, okay, that's the end of algebra.